In this video, you will learn how to multiply two vectors. If you don't know what a vector is yet, a vector is a mathematical object that has both magnitude or length and direction. And vectors are commonly used in physics, engineering, and mathematics to represent quantities like force, velocity, and displacement. And a vector can be written as this or as this in 2D. And in 3D, it can be written as this one. Let's say we're given this vector with components 3, 4. So this means this vector moves 3 units in the x direction and 4 units in the y direction. The magnitude or length of this vector can be solved using this formula. The length of v, vector v, is just the square root of the sum of, let's say this is x and this is y, so the sum of the square of x and y. So it can be represented as this one. And you have to take note that a vector with a 0 magnitude is called a zero vector, which is written as this one. And now that you understand what vectors are, we can do some operations with them. We can add and subtract them and multiply by scalars. So let's say we have vectors x. So let me just write that, x and y. So we can add vectors x and y. So that would be x, vector x plus vector y. Subtract them, vector x minus y, and multiply by a scalar. Let's say the scalar is c, so this would be c times vector x or c times vector y. But how do we multiply two vectors together? Actually, there are two different ways that we can multiply two vectors. One is the dot product, which is also called the scalar product or inner product. And the other one is the cross product. In this video, we will learn about the dot product. Alright, if we have some vector x, let's say vector x with components x sub 1, x2, and x3, and another vector y with components y1, y2, and y3, then its dot product is denoted in this way. So that would be x dot y. And this would be equal to x sub 1, y sub 1, plus x sub 2, y sub 2, plus x sub 3, y sub 3. So you just have to multiply their components. And it is very important to know that this is a scalar product. And the dot product doesn't give us another vector. It takes two vectors as an input, vectors x and y, and, okay, this one, the input, vectors x and y, and one number as an output, the result of the dot product, or the result of this one. Let's say, for example, if we're given vector x with components 2, 3, and vector y with components 4, 1, then the dot product of vectors x and y is just equal to 2 times 4 plus 3 times 1, and this is just equal to 8 plus 3, and this is just 11. Therefore, the dot product of vectors x and y here is equal to 11. And also, if vectors are perpendicular, let's say if vector x is perpendicular to vector y, let me draw that. Let's say this is vector x and this is vector y, and they are perpendicular, then the dot product of x and y, vectors x and y, is equal to 0. Since the dot product involves simple multiplication, it is commutative. So that would be, let's say we're given again two vectors x and y. So the dot product of vectors x and y is just equal to the dot product of y and x, which means it doesn't matter what order in which numbers are multiplied. And the distributive property also holds. Let's say we're given three vectors, x, y, and z. So vector x times, or the product of vector x and y plus z is just equal to the dot product of vectors x and y plus the dot product of x and z. And also, a scalar times a vector in a dot product is the same as the scalar multiplied by the dot product or the other combination, as this one. So let's say we have a scalar c in vectors x dot y is just equal to that scalar times the dot product of x and y, and this is just equal to x. Okay, let me write that again. X dot the scalar and vector y. And the dot product of a vector to itself, let's say x dot x, is simply equal to the length, all right, the length of a squared, or I meant the square of the length or magnitude of that given vector. And also the zero vector dot x, let's say the given vector is x, is just equal to 0. All right, another formula for dot product is by using an angle. Let's say we're given vectors x and y again. So x dot y is just equal to the length of x times the length of b times the cosine of the angle between them. So let's say this is vector x and this is vector y, and the angle in between them is theta. So we can solve them. We can find the dot product of x and y, vectors x and y, by using this formula. We just have to multiply the length of each of the vectors and cosine of the angle between them. So this means that if we want to calculate the angle between two vectors, we can just simply bring this vector, the vector lengths, to the other side of the equation, and we get the cosine of the angle. So we use this formula. And this is one of the reasons why dot product is very useful, because we can calculate angles without even doing any trigonometry. Let's say we're given these two vectors with components 3, 3, and negative 5, and another vector y with components 5, negative 2, 3. And we need to find the angle between these vectors. So the first thing we do here is we find the length of each of the vectors. So we find the length of x, and that is just equal to the square root of the sum of the square of each of the components. So that would be the square root of 3 squared plus 3 squared plus negative 5 squared. And this is just equal to the square root of 9 plus 9 plus 25. And this is just simply equal to the square root of 43. So this is the magnitude or the length of vector x. Then now we solve for the length of vector y. So that is just equal to the square root of 5 squared plus negative 2 squared plus 3 squared, and this is just equal to the square root of 25 plus 4 plus 9, which is just simply equal to the square root of 38. And the next thing we do is we get the dot product of the two vectors x and y. So that is just, we just multiply the components. So this is just 3 times 5 plus 3 times negative 2 plus negative 5 times 3. So let me just write here the length of vector x, which is square root of 43, so we won't forget it. Then the length of vector y, which is square root of 38. And let me delete this one. Alright, now we can get the dot product of vectors x and y. So this is just 3 times 5, that is 15, plus 3 times negative 2 is minus 6, plus negative 5 times 3 is negative 15. And this cancels out, so the dot product of x and y is just equal to negative 6. So now we can solve for the angle between these vectors. So we use this formula, cosine theta equals the dot product of the two vectors, and that is equal to negative 6, divided by the length of vector x, which is square root of 43, times the length of vector y, which is square root of 38. Using a calculator, we get cosine theta equal to the negative of 0.14843. And now to solve for the value of the angle between vectors x and y, we just use the inverse, cosine inverse. So theta here is just equal to the cosine inverse of this one, negative 0.14843. And this would give us an angle that is equal to approximately 98.54 degrees, or just simply 99 degrees. So this is the measure of the angle between the two vectors x and y. So it would look like this. It's 99, so it's obtuse. So this is vector x and this is vector y, and this is 99 degrees. And now we know how to find the dot product of two vectors. And as what I've mentioned earlier, that any two vectors that are orthogonal or perpendicular will always give a dot product equal to 0, because the cosine of pi over 2 or 90 degrees is 0. Let's say we have vectors x and y here, and this is 90 degrees or pi over 2. So the cosine of 90 degrees is just equal to 0. And that means that if the dot product of two vectors, let's say the dot product of vectors x and y is equal to 0, then that means these two vectors x and y are orthogonal or perpendicular. Now that's all for now. I will discuss the other way that we can multiply two vectors, which is the cross product.